Okay, so today we will start chapter number 12, Pythagoras theorem, right? So let's see about it. Okay, so this is the most important theorem that we have already discussed in trigonometry chapters. Okay, when we have learned the trigonometry chapter, then I told you about the basic things. What was the Pythagoras theorem, or we can, in short, we say that PGT. So what is that? In right triangle, suppose this is right triangle ABC. Okay, this is the hypotenuse H, this is the base, and this is the perpendicular. So hypotenuse equals to base square plus perpendicular square. Okay, that is the Pythagoras theorem. In a right triangle, the angle opposite to the right angle, the side opposite to the right angle, that is the longest side, and that is the hypotenuse. And the hypotenuse square is equals to the base square plus perpendicular square. So this is the PGT. So in this chapter, first we have to prove this theorem. Okay, in the exam sometime it is asked, prove that PGT. Okay, state and prove the Pythagoras theorem. So we have to give the statement that in a right triangle, the square of the hypotenuse is equals to the sum of the squares of its base and perpendicular. Then we have to prove it. So we can prove this by two methods. First method, that is given in your book. Okay, according to that we have to prove, and the second method, that is with the help of the concept of the similar triangle. That is the proof given in the 10th standard, in which you will learn chapter similar triangle. Okay, so you don't have learned that chapter. You have learned only congruence triangles. Okay, so in 10th standard there is one chapter, that is the similar triangle. So with the help of that concept we will prove this also, and by the method that is given in the book we will prove it. In your exams this may be asked to prove the theorem. So let's see this. Suppose this is a triangle ABC. This is right angle. Okay, and we can assume these sides, like suppose this is A, this is B, and this is C. Fine. So according to the theorem, we can say that C square is equals to A square plus B square. So this condition we have to prove, and so how we prove? So for proving this we need some constructions. Okay, so what we will do, we just extend this side. We are extending this side, and suppose we are taking any point like P, and the condition is that whatever the length of this side AC, we have to take this side same. Okay, we are extending this side equals to this side. So suppose this BP is equals to A. This is the condition. Whatever the altitude, or we can say the height of this triangle, the same base we have to take here. So this is just the construction that we are drawing to prove the theorem, right? So we have drawn this till this point, and the condition is that BP is equals to AC, right? Then the second step, we have to draw the perpendicular from this. Two construction we have to do. We are drawing perpendicular from here like this. Fine, and we are cutting this side equals to the base. Okay, so suppose this is equals to the base, and we are marking a point, any point you can take like Q. Okay, this is your right angle, 90 degree, and this side is B. Fine. Okay, now join this. Join this. Okay, we don't know about this side, and we don't need this now. Only what we have done in the construction, we have taken this base equals to this, and we are taking this altitude equals to this. Both are the right triangles. Fine. So this is the first step. Now what we will do, we just join this line. We can join this. So this is a figure, that is finally we are getting this. This is a right triangle, this is a right triangle, okay, and this one is a trapezium, we can say. This is the trapezium. Understood? ABQC is a trapezium because opposite sides are parallel. One pair of parallel sides are there. That's why this is a trapezium. Okay, so first step is that. So what construction we have done here? Let's see. Draw or BP equals to A through B. Okay, from here we are drawing a line that is equals to this. And secondly, we have drawn this right angle. So draw right angle, or we can say a perpendicular. Draw a perpendicular from P equals to, yes, equals to B at Q. At Q. Suppose this ending at Q. Now join this BQ and CQ. So therefore APQC is a trapezium. This is by the construction we have done. Okay, now we will prove this. So what we have to do this here, we know that this triangle and this triangle both are the right triangles, so they are congruent. Okay, they are congruent. We can prove that congruent. This side equals to this side equals to this, and this angle is equal to this. Of course they are right triangles, so they are congruent. So directly we can write these two triangles are congruent. So with the help of that, what we can do? We can say that this angle must be equals to this angle, right? By CPCT. So the first step is to prove two triangles congruent. So directly we can write in triangle ABC and triangle BPQ. AC is equals to BP and AB is equals to PQ. This is by construction. Okay, and angle A is equals to angle P. Same by construction. Therefore, these two triangles ABC congruence triangle BPQ, we can say by RHS rule, right? So therefore by CPCT we can take this angle. Suppose okay, we can give the name. Angle ACB is equals to angle PBQ. Reason is CPCT. Fine. This is the first step. Okay. So now what we will do? Actually we have to prove this angle equals to 90 degree. Okay, so that what we are going to do actually, because this trapezium is consist of three triangles, so the area of the total trapezium is equals to the sum of the areas of these triangles. Fine. So if we know this this triangle is a right angle, so we can find its area by using the formula half into base into height, right? So see that these two triangles are congruent. Okay, that we have proved. So by that we are taking this angle equals to this angle by CPCT, or we can take this side BC is equals to BQ, same by CPCT. So we can write this as C. Okay, so this BC is equals to BQ, CPCT. Okay, so you just write this. Okay, then we will move to the next. You can stop the video, I think.